Hello. My name is Stephen Hawking, physicist, cosmologist, and something of a dreamer. Although I cannot move,
and I have to speak through a computer, in my mind, I am free. Free to tour the universe and tell the ultimate story. The story of everything there ever was. From the moment the cosmos began, to the creation of our world and everything in it, and beyond, to the far, far future and the end of the universe itself. A journey through all of space and all of time.
check it out.
I spend a lot of time thinking about the universe, but I never get bored. After all, it's a pretty extraordinary place. This is the cosmos, at a very large scale. Each tiny point of light is an entire galaxy, each a cluster of as many as 400 billion individual stars. This view of the universe is only possible due to the latest supercomputers. I find it indescribably beautiful. Uncountable billions of galaxies forming a vast web stretching away in all directions. What's more, I never get over the fact that within this massive universe lies one perfectly ordinary spiral galaxy. Inside that galaxy exists a commonplace yellow star, orbited by 8 planets. On one of those planets lives a species that has only just worked out what a remarkable place the universe is. Us. We've discovered more about the cosmos in the last century than in all previous human history. Finally, we are solving the basic mysteries that have perplexed our ancestors for at least 200,000 years. What I like above all is that the facts themselves are both breathtakingly elegant and surprising. We're living just as it dawns on us that the Earth and everything around us was made by the stars. Boiling furnaces of hydrogen gas, like our sun, made even the atoms in your eyelashes. We've worked out that the universe is almost unimaginably ancient, about 14 billion years old, and that it will continue to exist for at least twice that long. But without a doubt, the most remarkable fact of all is that the entire enormous universe, all the innumerable galaxies, even time and space, and the forces of nature themselves, simply materialized out of nothing. So now is a good time to be alive, I think.
We may only be an advanced breed of monkey, living on a small planet, but we are able to contemplate the universe as a whole, which makes us very special. My goal has always been simple, to work out how the universe works, and why it exists at all. Luckily there are clues everywhere, and the most important one is right above our heads.
Examine any patch of the night sky, even one as small as the head of a pin, and this is what you'll find. A tiny part of the vast web of galaxies. It's less than a millionth of what we can see of the cosmos from our little planet. But even this tiny sample is enough to find the clue, the key to the past, the present, and perhaps the future too. The clue is that seen from Earth, all these distant galaxies are slightly red in color. They appear almost as if we were looking through rose-tinted glasses. It's this very redness that reveals how the universe was born. And to show you why, I need a straight road and a noisy car. Listen to the sound as it passes by. As the car approaches, the pitch of its engine rises. As it goes away, the pitch of its engine falls. This phenomenon is called a Doppler shift, and the exact same thing happens with light. If our eyes were more sensitive to color, we could see that the car is actually very slightly blue as it approaches, and very slightly red as it goes away. The same rules apply in space. All distant galaxies are slightly red in color. So by the exact same piece of basic physics, they must all be moving away too. In fact, the whole universe is expanding in all directions, getting bigger and bigger, like a balloon inflating. I admit this sounds strange, but to cosmologists, it's like winning the lottery. Because to work out where the universe came from, all we need to do is to stop time and make it run in reverse. Rewind far enough, and everything gets closer together. A lot closer together. All the galaxies, in fact, every single thing, converges to a single point, the start of everything, 13.7 billion years ago. So it's quite simple, really. Follow the clues, and we can deduce that a very long time ago, the universe simply burst into existence. An event called the Big Bang. But I'm afraid we have to stop a moment before we get carried away by fire and noise. At the very beginning, the Big Bang actually happened in total darkness because light didn't exist yet. To see it, we'd have needed some kind of cosmic night vision. But even this, a view from the outside, is impossible. Again, it sounds strange, but space didn't exist then either. So there was no outside. The only place there was inside. This early universe was a very strange thing indeed. There's still much I'd dearly love to know about it, but standard concepts of time or space don't really apply. It was just a very tiny, ultra-hot fog of energy. Then it expanded. With a tremendous flash of radiation. From smaller than an atom to about the size of an orange in less than a trillionth of a second. Almost no time at all. The universe simply inflated into existence, unfolding, unfurling, getting bigger and cooler with every passing moment. Within 100 seconds, it was as big as our solar system, trillions of miles across. While this was happening, the pure energy of the cosmos began to cool and create matter in the form of countless trillions of subatomic particles. The first stuff there ever was. Half these particles were made of matter, the same kind of stuff which makes us. The rest were made of the opposite of matter, stuff called antimatter. When the two meet, they destroy each other in a flash of energy. It seems as if building a universe is a pretty wasteful process. Fortunately, there was just a bit more matter than antimatter. Just 1 in a billion particles of stuff survived. Which was lucky for us, because that residue is what our present-day universe is made of. You could say that we are made of the smoke of the Big Bang. By the time the cosmos was 10 minutes old, it was already thousands of light years in diameter. After that, everything spread out and cooled for about 330,000 years, when finally the fog cleared and the universe became visible. So that's how everything got going, which I think is a pretty fantastic story, and probably much stranger than anything our ancestors came up with by way of an explanation. But the next thing that happened, well, that's pretty spectacular too. This is the universe seen in extreme fast forward. All 14 billion years in less than a minute. It shows how the universe changed from a cloud of gas into a place filled with perhaps 100 billion galaxies swirling in a vast, chaotic dance. What I'd love to get people thinking about is that all this had to be built atom by atom. Celestial engineering on a spectacular scale. So what drove this cosmic clockwork? I'd say it was the force of gravity. The idea of gravity was worked out by Sir Isaac Newton, who had the same job as me here at Cambridge University back in the 17th century. It supposedly dawned on him when an apple fell on his head.
The apple helped him realize that all objects attract each other. And the greater the mass, the stronger the pull. These apples are attracted to the earth, and although you can't see it, the earth moves very slightly up towards the apples. All things come together through the power of gravity. Gravity was created in the Big Bang, and has been at work ever since. It's what keeps you, me, and apples stuck to the earth. In the early universe, gravity had a much bigger role to play.
Right after the Big Bang, the universe was just gas, almost perfectly spread out throughout space. Over the next 200 million years, gravity began to pull the gas back together to produce the very first structures from which everything else would grow. But even this very nearly didn't happen. If it weren't for another stroke of cosmic luck, there would be no you, no me, no stars or planets or anything at all. We know this because in 1982 a group of scientists, including myself, spent 3 solid weeks working it out. Although the calculations were hard, demonstrating what we discovered is easy. First, I need a nice flat floor, like this one, for example. This is the dining room in my college. I'm going to fill the place with lots and lots of ball bearings. These balls represent the matter of the early universe, a thin gas spread out evenly across the vast cosmos. Here's where luck comes in. If they're all the same distance apart, gravity pulls each ball the same amount in all directions. They stay perfectly aligned, and precisely nothing happens. Fortunately, one of the basic rules of the universe is that nothing's perfect. Perfection simply doesn't exist. The early universe had a tiny unevenness that can be simulated by removing just 5 ball bearings. It may not look like much has changed, but to gravity, those missing balls create a giant opportunity. Gravity now pulls more strongly on one side of some of the bearings. The tiny irregularities in the sea of ball bearings have given gravity something to sink its teeth into. And this is exactly what happened back where we left the young universe. Parts of the sea of early gas were ever so slightly thinner than others. The less dense areas were like the gaps between the ball bearings. the denser parts of the sea of gas, where gravity was having its way, clumped together. And it was in these areas that all the stars and galaxies would form. The cosmos had taken its first step towards the beautiful place it is today. All thanks to irregularity, imperfections, a lack of order. So next time someone complains that you have made a mistake,
Tell him that may be a good thing, because without imperfection, neither you nor I would exist.